Hey guys, did you know that China has earned the nickname Infrastructure Maniac? This nickname is not derogatory. It reflects foreigners' astonishment at the speed of China's development. In today's video, we will bring you mighty Chinese construction technology whose engineering shocks America's engineers to the bone. But before we dive in, we kindly ask you to show your support by liking this video and subscribing to Machine Eye. We value your thoughts and invite you to share your opinions on these remarkable construction technologies in the comments below. Without further ado, let's embark on an extraordinary journey. On this planet, there exists a type of engineering marvel that inspires awe and pride in equal measure: bridges. In this realm, China is redefining the meaning of bridges with its technology, perseverance, and innovation. From cable-stayed bridges spanning deep mountain valleys to super projects crossing vast oceans, China, often called the infrastructure giant, has claimed the pinnacle of global bridge engineering. When Jeremy Clarkson first came to China, he was amazed by the country's infrastructure.
China's road network. In 1988, China had no motorways at all. And now, 30 years later, it has 84,000 miles of them. That's more than any other country in the world. And they're only just getting into their stride. Since 2011, they've been building 6,000 miles of motorway every year. 6,000 miles a year! It beggars belief, and it's not like the terrain is easy. Here, though, there ain't no mountain high enough, and there ain't no valley low enough to stop them. This bridge, for example, is 34 miles long. And then there's this one, the Beipan Bridge. You could fit the London Shard underneath it, twice over. I'm telling you, in Britain, we're doomed.
Chinese engineers also accomplished the remarkable feat of building a train station in just 9 hours, sparking heated discussions and debates internationally.
How the Chinese do these things, they were able to build a whole new station in the space of 9 hours by flooding it, thousands of workers. We should be much more imaginative about getting infrastructure in instead of condemning people to being isolated in remote areas.
Was it 9 hours they built?
9 hours.
Sounds
Look
like
it
a
up.
television reality
there is
show.
a video here. You've got to watch
get the workers
this
out to take the
Nice.
In Beijing, China, Chinese workers rebuilt a flyover bridge in just 43 hours. In 2015, the Sanyuan Bridge in Beijing underwent a heart-stirring rebirth. An unprecedented project to replace all beams catapulted this busy traffic artery to a historical pinnacle. In a mere 43 hours, at a seemingly magical pace, a brand new bridge emerged, rising from nothing, once again bursting with vitality. Many foreign netizens have praised the speed of construction in China. Some say that in their country, it would take at least 5 years, while others claim it would take the term of a president to complete half of the project, leaving the other half to the next president. From this perspective, China's efficiency is truly remarkable. Meanwhile, a professor from the United States, upon hearing the news that China had completed the construction and opening of the bridge in just 43 hours, exclaimed in disbelief, completely unable to understand the construction efficiency of Chinese engineering.
China has actually soared. It's meteoric. Former Czech President Václav Havel, I think, put it best. He said, all this has happened so fast, we haven't yet had time to be astonished. To remind myself how astonished I should be, I occasionally look out the window in my office in Cambridge at this bridge which goes across the Charles River between the Kennedy School and Harvard Business School. In 2012, the state of Massachusetts said they were going to renovate this bridge. It would take 2 years. In 2014, they said it wasn't finished. In 2015, they said it would take 1 more year. In 2015, they said it's not finished. We're not going to tell you when it's going to be finished. Finally, last year it was finished 3 times over budget. Now, compare this to a similar bridge that I drove across last month in Beijing. It's called the Sanyuan Bridge. In 2015, the Chinese decided they wanted to renovate that bridge. It actually has twice as many lanes of traffic. How long did it take for them to complete the project? 2015. What do you bet? Take a guess. Okay. Take a look. The answer is 43 hours. Now, of course, that couldn't happen in New York, yes.
As the first vehicle slowly drove across the new bridge, enthusiastic applause and cheers erupted at the scene. At this moment, all the hard work paid off, and all the efforts turned into this brand new bridge. It is not only a bridge connecting roads, but also a bridge connecting hearts, witnessing the glorious achievements of Beijing's urban construction. China next door neighbor India on the west border is always busy with their ton of boastful hypes, self-praise on their leadership, chanting superpower, dreaming of replacing China as world manufacturing country, but with not much real achievement, progress, and result. For instance, India plans to construct a railway bridge taller than the Eiffel Tower, named the Chenab Railway Bridge, located in the Jammu and Kashmir region. The bridge is designed with a lifespan of 120 years and a height of 359 meters, surpassing the Eiffel Tower by 35 meters. Construction on this bridge began as early as 2002, with the original completion target set for 2009. However, it was abruptly halted in 2008. The project remained at a standstill. In 2010, construction resumed, with Indian media claiming it would be finished by 2016. However, reality proved astonishing. By 2016, only the Bach Bridge pier of the Chenab Railway Bridge had been completed. Full construction resumed in 2017, and due to various reasons, the planned completion was further delayed to 2019. This series of setbacks has led to a prolonged delay in the completion of the Chenab Railway Bridge. The primary reasons include India's weak overall capacity, coupled with the high cost of construction materials, exacerbating India's already challenging economic situation. Furthermore, India lacked experience and technical expertise in the construction process, resulting in frequent issues and a decline in construction speed. Ultimately, the Grand Bridge took 21 years to complete, and it is expected to be operational by 2024. In summary, although India's Chenab Bridge incorporates high-tech materials and advanced construction techniques, surpassing China's infrastructure prowess remains a formidable challenge. Let's take a look at the super bridge built in China at a cost of nearly 800 million, the Yachi Bridge. This grand bridge stands atop a cliff at an impressive elevation of 434 meters, with a total length of 1,200 meters. So, what was the level of difficulty in constructing this bridge? With a magnificent main span of 436 meters and a total length of 971 meters, the Yachi Bridge is not only the world's largest continuous rigid frame bridge with a steel-concrete composite deck and a cable-stayed basket handle arch, but also the longest span high-speed railway bridge of its kind. The construction of the main tower's reinforcing steel used a groundbreaking method where steel was bound and formed into shape on the ground before being lifted and installed on the tower columns. The hydraulic climbing formwork employed a system with fewer pole rods, enhancing the appearance and quality of the tower columns' concrete. The connection of the bridge's steel truss arches involved precision welding and bolting, demanding extremely high machining and assembly accuracy, controlled to within millimeters. Any deviation exceeding 2 millimeters could result in misalignment of the bolted joints. The entire bridge required approximately 130,000 cubic meters of concrete, and the steel used in the truss beams amounted to over 16,000 tons. In the gorge where the bridge is situated, instantaneous wind speeds can reach up to force 10. The cable tower's top is 110 floors above the Yachi River surface, posing extremely high construction safety risks. American engineers boldly claimed that China couldn't complete such a project due to its complexity. However, Chinese engineers overcame numerous challenges, successfully completing the Yachi Bridge, showcasing the dominance of Chinese bridge construction technology and marking a significant milestone in the development of the Chengdu-Guiyang high-speed railway. Let's start with one of the most renowned bridges in the world, the Kong-Zhuhai-Macau Bridge. As its name suggests, this bridge connects Hong Kong, Zhuhai, and Macau, spanning the Lingding-Guiyang waters. It stretches 55 kilometers, making it the longest sea-crossing bridge in the world. However, it is more than just a bridge. It is a bridge-island tunnel combination project. To allow the bridge to cross busy shipping lanes, engineers constructed a 6.7-kilometer-long underwater immersed tunnel. Each segment of the tunnel weighs 80,000 tons, equivalent to the weight of an aircraft carrier. How challenging is it to install an immersed tunnel? For instance, the alignment tolerance during the connection of each tunnel segment cannot exceed 2 centimeters. Yet in deep waters where currents, silt, and pressure are major challenges, achieving such precision seems nearly impossible. But Chinese engineers turned the impossible into reality with their cutting-edge expertise. After relentless efforts, a world-shocking underwater tunnel was successfully completed. This raises a question. With the sea filled with water, how did Chinese engineers manage to construct this underwater marvel? Let's dive deeper into the process. There are 4 common methods for constructing underwater tunnels. The drill and blast method, which uses explosives, the TBM and shield tunneling methods, suitable for hard rock and soft soil respectively, and the immersed tube method, which involves lowering pre-made pipe sections onto the seabed and connecting them. The drill and blast method, also known as the mining method, involves using explosives to carve out a section, removing the rubble, and lining the tunnel walls. This cycle repeats until the tunnel is complete. Since blasting can disrupt surrounding rock layers, this method is often used in stable geological conditions. When fractures in rock formations cause water seepage, engineers must inject grout to create a watertight barrier for stability. China's first underwater tunnel, the Xiamen Tunnel, was built using this method. TBM and shield tunneling methods involve large drilling machines. TBMs are used for hard rock environments, while shield machines excel in soft soil layers and feature waterproof capabilities. These machines simultaneously excavate and assemble concrete segments to support surrounding rock, preventing tunnel collapses. The shield tunneling method is particularly versatile due to its full mechanization. Lastly, the immersed tube method involves submerging prefabricated tunnel segments and connecting them underwater. Waterproofing the connections is critical. The Kong-Zhuhai-Macau Bridge's tunnel was built using this method. Constructing an immersed tunnel is a complex and precise process, akin to crafting a masterpiece. The first step is building a dry dock, similar to a shipyard. Engineers excavate a massive rectangular water tank near the tunnel site and use techniques like slope excavation and diaphragm walls to ensure a level base and watertight conditions. This creates a solid foundation for fabricating the tunnel segments. Within the dry dock, steel reinforcement cages form the skeleton of the tunnel segments. Concrete is then poured into molds to create the segment walls. After curing, engineers maintain optimal concrete quality using ultrasonic mist cooling internally and geotextile and blankets externally for moisture retention. Outfitting the tunnel segments is a critical phase, including installing ballast water systems, pipelines, and monitoring systems. The segment's exterior surfaces are coated with polyurethane to ensure waterproofing. The ends of the segments, crucial for connection, are equipped with steel bulkheads, waterproof gaskets, and sealed doors to maintain integrity during installation. Once outfitting is complete, the dry dock is flooded, and the segments undergo rigorous testing to ensure their readiness for transport and installation. The foundation trench for the immersed tunnel must be meticulously excavated. Large dredgers handle rough excavation, smaller dredgers perform precision digging, and leveling vessels finalize the surface. The riverbed's flatness error must not exceed 4 centimeters to enable precise placement of the segments. Next comes the most exciting phase, segment transport and installation. Tugboats and anchor cables position the segments at the designated location, guided by Beidou navigation and digital monitoring systems for millimeter-level accuracy. During installation, engineers flood the segments to gently lower them into the trench and align them for connection. This phase demands exceptional technical expertise and teamwork. After installation, the segments are reinforced with gravel backfill, geotextiles, and anti-scour stone cages to ensure structural safety and long-term stability. Finally, the interior of the tunnel is equipped with electrical systems, fire prevention setups, and decorative finishes. High-quality roadways are laid to ensure the tunnel meets transportation and safety standards. From dry dock construction to segment alignment, every step of the immersed tunnel's creation exemplifies engineering precision. The Kong-Zhuhai-Macau Bridge's tunnel not only conquered nature's barriers but also showcased Chinese engineers' ability to push the boundaries of innovation. This is Qingdao. This young coastal city has now become the third largest city in northern China in terms of economic output, ranking just behind Beijing and Tianjin. It is nestled by the coast and vying for attention with an explosive twist. That's right. Beneath the waves is right at the construction site of the Jiaozhou Bay second undersea tunnel, soon to be the world's lengthiest underwater highway. But Qingdao isn't new to smashing records. A dozen years back, they dropped the mic with the Jiaozhou Bay Bridge and Tunnel, stealing the spotlight as the planet's longest cross-sea bridge and China's reigning underwater tunnel champions. So, what's cooking with this new world record and Qingdao's sudden passion for sea-spanning structures? Well, let's rewind and appreciate Qingdao's cozy embrace of Jiaozhou Bay, which, believe it or not, was once just an ordinary basin. A mere 11,000 years ago, a bit of sea level drama transformed it into the spectacular Jiaozhou Bay we see today. With its deep, expansive harbor and impeccable geography, Qingdao proudly houses the world's 4th largest port, Qingdao Port, and it's not just a port, it's the heart of the city. On the bay's east side, you'll find the old city of Qingdao, while to the west, the West Coast New Area, affectionately known as Huangdao, has taken shape. 3 decades ago, crossing the bay meant leisurely ferry rides, taking a whole hour to get across, not exactly a whirlwind. Things got a bit speedier with the Coastal Bay Highway, trimming the journey to a brisk 50 minutes. But the real game changer arrived in 2011 with the Jiaozhou Bay Bridge and Tunnel, slashing travel time to a jaw-dropping 6 minutes. Suddenly, Qingdao's free trade zone, economic development zone, port hubs, and the legendary Qingdao International Beer Festival all relocated to the West Coast New Area. Cross-bay traffic went through the roof, with nearly 200,000 vehicles making the journey daily. To earn its title as a true bay city, Qingdao needed a fresh cross-sea passage, one that doesn't tick off Poseidon, scoffs at strong winds and fog, and keeps the travel vibes alive around the clock. Enter the Jiaozhou Bay second undersea tunnel now under construction, but it's not without its challenges. Stretching for a whopping 14.37 kilometers, it boasts 6 lanes in each direction and plummets to depths of 115 meters below sea level. Talk about tunneling into the unknown. This tunnel has to face 2 distinct rock formations. On the Huangdao side, it's all about rugged granite, while Qingdao's soft gray limestone and sandy layers add a twist. Plus, there are 22 faults lurking around, with the Big Daddy named Sanko Fault, a behemoth spanning over 200 meters. It's like a line in the sand, separating flat plains in the west from hilly terrain ruled by Wufeng Mountain in the east. Now, how do you drill through this geological maze? There's the drill and blast method, great for both hard and soft rock. Then there's the shield tunnel boring machine, TBM, method and the immersed tube method. Immersed tubes are costly and messy for the environment, so they're out. Faced with a cross-sectional diameter of 15.6 meters and water depths exceeding 100 meters, the TBM construction method carries significant risks, and therefore, it is also ruled out. So, considering the distribution of rock formations, combining drilling and blasting with shield tunneling is the most reliable construction method. Start with drill and blast, a real rock and roll show, with engineers drilling 254-meter deep holes into granite faster than you can say explosives. Speaking of which, those sausage-looking explosives fit snugly into the holes and, with precise placement, blast the rock into shape. But there's more to do, as these blast holes need 3 layers of reinforcement, inner and outer concrete jackets with a waterproof layer in between. And there you have it, a tunnel in the making. Yet, the real cliffhanger isn't the rock, it's the lurking faults, waiting to crash the party. The fragile rock here demands caution, or a floodgate of groundwater or seawater could wash everything away. So, radar scouts ahead, and if conditions look dicey, holes are drilled and cement injected to fortify the fissures. This solid barrier not only blocks water but strengthens the tunnel, letting it inch forward through the colossal Sanko Fault at a slow and steady pace of 2 to 3 meters per day. Now, for the softer limestone zones, it's time for the shield tunneling method. Behold the legendary tunnel boring machine, TBM, an 8-meter-wide juggernaut with a cutter head that eats rock for breakfast. It grinds boulders into mud and pumps them out through pipes. Simultaneously, the TBM hoists up concrete segments to create a seamless tunnel lining. It's like a giant palm holding up a 1-ton weight, a true showstopper. Afterward, this colossal machine gets disassembled, transported to a 30-meter deep pit, reassembled, and heads off to conquer the seabed. But here's the kicker, finishing the main tunnel doesn't mean the end of the adventure. What about exhaust gases? What if construction drags on, or heaven forbid, accidents occur? Enter the hero of our story, the service tunnel. It's not for regular traffic, but it's the control center for tunnel wizardry, maintenance, pipelines, and emergency escapes. It's the tunnel's hidden superhero, working side by side with the main tunnels. And the big reveal? How do those eastbound and westbound tunnels meet? Imagine an epic chamber beneath the sea, a 30-story behemoth serving as the tunnel's junction and a launching pad for the TBMs. It's not just any chamber, it doubles as a ventilation hub, a feat most undersea tunnels manage with towering ventilation buildings. But not here. They're keeping things marine-friendly by placing those towers on land. The service tunnel, free of vehicles and exhaust, acts as the air channel, splitting the 10-kilometer ventilation distance into 2 neat segments. By the end of 2027, this colossal tunnel will be ready to steal the show. And when you walk through it, don't expect flashy lights or red carpets. It's all about subtlety, hidden beneath the seabed, letting marine life and shipping carry on undisturbed. Super projects don't need to shout. They can make a powerful statement by being remarkably unobtrusive and gentle. So, there you have it. With the might of these super tunnels, Qingdao is set to become a bona fide Bay City. Who knows, along China's extensive coastline, from the 20-kilometer Jiaozhou Strait to the 100-kilometer Bohai Strait and the 130-kilometer Taiwan Strait, more natural barriers may soon yield to Chinese engineering genius one by one. Cue the epic tunnel music. The Jiaozhou Bay second undersea tunnel. China's mega projects are one of awe and inspiration, a testament to Chinese engineers' ingenuity, innovation, and relentless pursuit of progress. Now, let's travel to southwestern China to visit the Beipan Bridge, a ladder to the heavens suspended in the clouds. The bridge stretches 1,341 meters in length and soars 565 meters above the valley floor, making it one of the world's highest bridges. Standing on it feels like the entire world lies beneath your feet. During construction, workers had to anchor foundations into steep cliffs and erect the structure layer by layer. Battling fierce winds and thick fog, they overcame life-threatening challenges to turn an insurmountable chasm into a vital connection. When China announced its plan to invest 1 billion yuan in the construction of the Beipan River Bridge, American experts predicted it would take China 300 years to complete this monumental project. To everyone's amazement, Chinese engineers defied expectations and completed the colossal undertaking at an unimaginable speed, leaving the once mocking American experts silenced.
Oh God, please, no! No!
In reality, it took only 3 years for China to successfully finish the Beipan River Bridge. One can only wonder how long it might have taken if the project were undertaken by the United States. Feel free to share your thoughts in the comments. The rugged terrain and extremely poor transportation conditions in the Guizhou region had a profound negative impact on the local population's economic development. Therefore, in 2013, China decided to construct a world record-breaking bridge at the intersection of Yunnan and Guizhou provinces to completely transform Guizhou's harsh transportation environment. However, this plan faced mockery from Western bridge expert Smith. With a height of 565 meters, equivalent to 200 floors, surpassing even the tallest U.S. structure, the World Trade Center at 412 meters, foreign media rushed to report on the seemingly impossible project. Smith, after inspecting the Beipan Grand Canyon, asserted that even with American technology, it would take 300 years to complete, suggesting China would need at least 3,000 years. Despite the ridicule, Chinese engineers courageously faced the challenge, determined to make Beipan the world's highest bridge. However, the engineering team was undeterred by external mockery and dedicated themselves wholeheartedly to the construction. Situated in a canyon with a main bridge length of 1,341 meters, traditional bridge pier construction in the canyon was impossible. Considering wind risks, the construction team opted for cable-stayed bridge technology. During construction, Chinese engineers innovatively employed longitudinal movement and hanging assembly techniques for the first time, lifting and assembling the 12-meter, approximately 160-ton steel trusses in midair. Precision alignment of 27 mm diameter bolts was essential. Despite the fierce canyon winds, Chinese engineers overcame every challenge, demonstrating their ability to tackle any obstacle. To address challenges like impassable rivers for traditional ship transport of cut-off beams, engineers adopted new methods. Beams were disassembled into smaller pieces, transported to the site by trucks, and assembled like building blocks, accelerating the installation process, shortening the construction period, and reducing damage to the bridge piers. Additionally, for the steel cables lifting the bridge deck, China's engineering team used one of the strongest materials with a compressive strength exceeding 1860 MPa and a dynamic load yield strength reaching 250 MPa. This material greatly ensured the stability of the bridge under strong winds and water vapor erosion, guaranteeing the project's safety. We see the deck of the Beipan River Grand Bridge connected to its towers, with steel cables spanning 250 feet, enough to stretch from New York City to Washington, D.C. To construct this unprecedented architectural marvel, Chinese engineers had to tackle numerous challenging engineering feats. The bridge spans the isolated depths of the Guizhou Grand Canyon, making it an epic engineering endeavor. Between two iconic towers, it stretches over a mile-long deck. Supported by 250-foot steel cables, it carries an incredible 22,000 tons of weight. This bridge can arguably be deemed the most colossal bridge structure on this planet. Through this project, China not only showcased its strength, providing effective support for poverty alleviation projects in Guizhou and Yunnan, but also defeated foreign experts who once mocked China. In fact, even the United States, with its arrogant statements about China, couldn't guarantee the completion of the Beipan River Bridge. This bridge stands as a milestone in China's infrastructure development, serving as an irreplaceable transportation hub. In 2016, with a cost of 1 billion yuan and a construction time of 3 years, the Beipan River Bridge, standing at a height of 565.4 meters, successfully set a new Guinness World Record. China's achievement completely contradicted the initial mockery from the famous American bridge expert Smith, who claimed it would take at least 3,000 years to complete. Located in the central part of the Yunnan-Guizhou Plateau, overcoming steep terrain and complex geology, the Beipan River Bridge has shortened the travel time between Yunnan and Guizhou to just 1 hour, bringing new hope to this land and becoming a source of pride in China's bridge construction. The completion of the Beipan River Bridge signifies another miracle in the history of global engineering. We head to the Longjiang Suspension Bridge in Yunnan, China. This bridge connects the cities of Baoshan and Tingchong and stands at a height of 300 meters, equivalent to the height of a 100-story building. The bridge is located in a seismic zone with a history of strong earthquakes. To ensure the bridge's safety, engineers employed advanced seismic technologies and materials, but you can imagine the feeling of experiencing an earthquake on a bridge 300 meters high. It's bound to be hair-raising. Yet, that's just the beginning. We'll soon see even higher and more dangerous bridges. The Siju Bridge spans the Sida River, linking Inchi-Tujia and Miao Autonomous Prefecture in Hubei Province with Fingjie County in Chongqing City, serving as a vital connection between China's central and western regions. It stretches approximately 2.5 kilometers and soars to a height of 560 meters, surpassing the Empire State Building in height. Constructing this bridge posed an immense challenge due to its location nestled between two towering mountains, spanning a deep and precipitous valley. Engineers even used rockets to launch the first cable across. After 3 years of grueling efforts, this bridge was finally completed. Driving on this bridge allows you to enjoy magnificent landscapes in a thrilling experience. But this is not the world's highest bridge. That title belongs to another Chinese bridge. Additionally, the Jiaozhou Bay Bridge, the world's third longest sea bridge, links Ningbo and Shanghai, spanning 36 kilometers. Built in a region notorious for its treacherous tidal conditions, the bridge overcame what was once considered a no-go zone for construction. It has since cut travel time between the two cities and spurred economic growth in the Yangtze River Delta region. China's dominance in bridge engineering stems from its advanced technology. For instance, China's steel structures are world-class. The Kong-Zhuhai-Macau bridge alone used over 420,000 tons of steel, enough to build 60 Eiffel Towers. This steel is not only incredibly strong but also resistant to marine corrosion, ensuring a lifespan of 120 years. China has also established a fully integrated bridge construction industry, from design to manufacturing. During the construction of the Kong-Zhuhai-Macau Bridge, all lifting equipment, transport vessels, and prefabricated components were made in China. This self-reliance reduced costs and significantly boosted efficiency. China's diverse terrain, including plateaus, mountains, plains, and seas, serves as a stage for engineers to innovate. From the Lus Plateau to the Tibetan Plateau, and from the Pearl River Delta to the Bohai Bay, each bridge is a testament to ingenuity tailored to local conditions. The significance of bridges goes beyond connecting two sides. They reshape transportation networks. The Kong-Zhuhai-Macau Bridge reduced travel time between Hong Kong and Zhuhai from 3 hours to 30 minutes, strengthening regional ties and injecting new vitality into the Pearl River Delta's economy. Bridges also transform entire regions. For example, Guangxi's Pingnan Third Bridge, one of the world's largest arch bridges, has improved travel for local residents while boosting tourism and logistics industries. China's bridge-building prowess is making waves internationally. The Padma Bridge in Bangladesh, built with Chinese expertise, is hailed as a lifeline for South Asia's economy, solidifying China's reputation in global infrastructure. Looking ahead, China plans to construct more deep-sea bridges, connecting distant islands to the mainland. This not only presents technological challenges but also reflects a vision for global connectivity. Artificial intelligence and IoT technologies are also being integrated into bridge construction. Future bridges may feature smart monitoring systems to detect issues early, optimize traffic flow, and enhance efficiency. Can you imagine driving from China to Europe one day? While it sounds like science fiction, advances in technology may turn transoceanic or transcontinental bridges into reality. Each bridge is a dialogue between humanity and nature. China's bridges are not just feats of engineering. They symbolize the intelligence and determination of the Chinese people. When you stand on these bridges, they connect more than just two shores. They connect us to the future. Chinese bridges are telling the world, China doesn't just build bridges, it uses them to connect the entire world. China is the land of bridges, the birthplace of countless iconic structures. As Mr. Mao Yisheng once said, bridges are a reflection of a nation's culture. Today, China's bridge construction capabilities rank among the world's best, with an average of 20,000 new bridges built each year. These achievements are significant not only in terms of technological innovation and engineering expertise, but also in driving regional economic growth. China's bridges, proudly made in China, are a testament to its engineering prowess, inspiring awe and excitement. Advances in new structures, materials, equipment, and technologies, especially their application in long-span bridges, have propelled China's bridge-building capabilities to world-leading levels. Notably, numerous long-span, heavy-load, and high-speed bridges have been completed, greatly enhancing China's status in global bridge construction history. According to incomplete statistics, 6 of the world's top 10 longest-span suspension bridges are located in China. Among them, the Wufeng Mountain Yangtze River Bridge stands as a milestone, a kilometer-scale dual-use suspension bridge for both rail and road traffic. Its completion marks China's pioneering use of suspension bridge designs in high-speed railway construction, solidifying the nation's leading position in large-span bridge-building technology. The Wufeng Mountain Yangtze River Bridge, as the world's first high-speed railway suspension bridge, sets an example for future projects. The Chinese standards it established are undeniably of global significance. It has brought China's high-speed rail into the suspension bridge era. More importantly, it ensures that the name China is the first to appear in the records of high-speed railway suspension bridges worldwide. The world remains the same, but China is no longer the same China. With the infrastructure powerhouse taking on the heavy responsibility and historical mission, it will continue to push forward, innovate, and drive China's giant ship steadily toward a promising future. As an ancient Chinese saying goes, if you want to prosper, build roads first. Indeed, transportation is the cornerstone of economic growth and a critical foundation for development. Only when people and goods can flow smoothly can prosperity truly flourish. In just 3 decades, China has quintupled its road network, built the world's largest expressway and high-speed rail systems. In addition, a mega network of unprecedented scale is now stretching out across China. This network is composed of a 48,000 kilometers ultra-high voltage power transmission line, a 115,000 kilometers natural gas and crude oil pipeline, a 146,000 kilometers railway network, and a 5,198,000 kilometers highway network, many of which are ranked top in the world. These achievements are not only miracles in the history of economics and construction, but also a proud marvel of the Chinese civilization which hasted for 5,000 years, as well as a solace for our predecessors who endured the century of humiliation. Roads, like veins in a living organism, connect people's vibrant, everyday lives to these massive engineering feats. In 1937, the first modern bridge designed and built by the Chinese was the Beam Bridge. Although it was blown up by Mr. Mao Yisheng, who designed the bridge, only 89 days after completed, it still opened a way of life for more than 100,000 people to escape the war. This is the Qiantang River Bridge in Hangzhou, whose maximum span is about 66 meters. With one beam on two adjacent piers, it is called simple supported beam bridge. And if its beam is extended to form one beam on multiple piers, then it evolves into a continuous beam bridge. Since the beam is continuous and uninterrupted and the front and rear can be mutually restrained, the load capacity is higher and the span of the bridge also increases. For example, the Yangtze River Bridge in Wuhan has a maximum span of 128 meters. With its help, Chinese people crossed the Yangtze River for the first time. But for China at that time, these steel bridges were so advanced and expensive that could basically only be used for railway construction. Fortunately, a new technology was gradually popularized in China, which has very ingenious principles. By placing pre-stretched rebar into the concrete and using the rebar's shrinking desire to balance the external force, the beam can therefore bear a larger load than before, and thus support larger spans. It is called pre-stressed concrete technology. Compared with steel, concrete is obviously much cheaper. So, with the support of pre-stressing technology, a large number of highway bridges have entered the history stage. Among them, modern suspension bridges are a prime example. Soaring bridge towers, curved main cables and solid anchorages constitute its most basic load-bearing system together. Unlike old rope bridges, modern suspension bridges have exceptionally tough main cables. Take the Wufeng Mountain Yangtze River Bridge in Jiangsu as an example. Its main cable is made of high-strength steel wire with a diameter of 5.5 mm as the basic material, 127 wires in a bundle, 352 bundles to one cable. With double cables in parallel, the weight of the steel beam carries exceeds 70,000 tons, equivalent to 1,000 fully loaded C-919 aircraft. Compared with such a huge beam, the traffic on the bridge seems insignificant. So, the deck is no longer like the old rope bridge fluctuating up and down due to external force. It even allows 4 high-speed trains to pass at the same time and becomes the world's first high-speed rail suspension bridge. So, the Wufeng Mountain Yangtze River Bridge, hailed as the world's first suspension bridge designed for both road and rail use. Do you know how it was built? Let's dive into the details together. China's bridge-building prowess is truly unmatched, leaving other nations far behind. The spectacular Wufeng Mountain Yangtze River Bridge consists of 2 cable towers, 2 main cables, 2 rows of suspenders, a main bridge deck, and 2 massive anchorages. The upper deck of the bridge supports an 8-lane highway, while the lower deck accommodates for high-speed railway tracks. The total weight of this section is a staggering 170,000 tons, equivalent to 3 fully loaded Liaoning-class aircraft carriers. The main cable wires, connected end-to-end, could wrap around the Earth 4.5 times. It took Chinese engineers up to 58 months to complete this colossal structure. All these efforts were dedicated to fulfilling a dream that spanned generations. Let's keep watching. To support such immense weight, the foundations of the 2 bridge towers must be rock solid. During the construction of Pier 3, workers first drove a series of steel pipe supports into the Yangtze River and built a working platform atop them. Next, 70 large steel casings, each with a diameter of 3.1 to 2.8 meters, were inserted into drilled holes over 100 meters deep. Steel reinforcement cages were then placed inside, and concrete was poured to form an incredibly sturdy cluster of piles. Similarly, Pier 4 relied on 67 steel casings, each with a diameter of 2.8 meters, extending between 60 meters and 138 meters underground. These steel pipe piles provided the robust support necessary for the construction of the tower foundations. The pile cap for Pier 3 resembles a colossal dumbbell, with a circular diameter of 40 meters, a total length of 95.94 meters, and a thickness of 9.5 meters. Since the steel pipe piles for Pier 3 were underwater, a dry working environment was essential. Ingenious Chinese engineers devised an innovative solution. They prefabricated 3 massive 10-meter-tall dumbbell-shaped steel shells in a factory. Using 2 large cranes, the shells were sequentially installed over the steel pipe piles, and water was pumped out to create a dry workspace. On Pier 4, where the steel piles were above water, engineers added a protective ring of steel sheets around the construction site to prevent collapse and ensure safety. With the pile caps completed, the two towering main towers began to rise. Built using hydraulic climbing techniques, Tower 3 reached a height of 203 meters, while Tower 4 reached 191 meters. The next step involved constructing the two giant anchorages. Due to differing geological conditions, engineers adopted different methods. The north anchorage used a caisson design, measuring 100.7 meters by 72.1 meters, making it the largest caisson foundation in the world. With a total height of 56 meters, the caisson was constructed by alternately adding layers and excavating soil until it was embedded 55 meters underground. Upon completion, the north anchorage weighed an astonishing 1 million tons, the equivalent of 1.33 million adults. The south anchorage featured a circular foundation with a diameter of 90 meters and a maximum depth of 40 meters. To prevent landslides around the foundation pit, engineers dug a 1.5 meter wide trench, dozens of meters deep, around the site. They installed steel reinforcement cages and poured concrete to form a solid underground retaining wall. With this protection, construction of the south anchorage proceeded smoothly, and its final weight also reached 1 million tons. With the foundations completed, the project moved to the main cable installation phase. Engineers first built two 2,000-meter-long catwalks between the towers. Using traction equipment, they pulled strands of steel wire into position. Each strand comprised 127 steel wires, each 5.5 millimeters thick, and each main cable contained 352 strands. The combined weight of the cables reached 16,000 tons. The strands were compressed into cylindrical shapes with a diameter of 1.3 meters, making them the world's thickest suspension cables and inspiring great confidence in their strength. The final stages included installing the suspenders and steel truss girders for the bridge deck. These components were lifted and assembled by cable hoists. Each steel truss girder was 46 meters wide and prefabricated in a factory before being transported by large vessels to the construction site. The installation began with segments lifted onto the crossbeams of the main towers and then proceeded symmetrically from the center span toward both ends, culminating in a final connection. With additional bridge facilities completed, the world's first road-rail dual-use suspension bridge was fully finished on June 30, 2021. The Wufeng Mountain Yangtze River Bridge has not only set a benchmark for future high-speed rail suspension bridges but also demonstrated China's exceptional engineering capabilities, earning admiration from engineers worldwide. China is the land of bridges, the birthplace of countless iconic structures. As Mr. Mao Yixing once said, bridges are a reflection of a nation's culture. Today, China's bridge construction capabilities rank among the world's best, with an average of 20,000 new bridges built each year. These achievements are significant not only in terms of technological innovation and engineering expertise, but also in driving regional economic growth. China's bridges, proudly made in China, are a testament to its engineering prowess, inspiring awe and excitement. Advances in new structures, materials, equipment, and technologies, especially their application in long-span bridges, have propelled China's bridge-building capabilities to world-leading levels. Notably, numerous long-span, heavy-load, and high-speed bridges have been completed, greatly enhancing China's status in global bridge construction history. According to incomplete statistics, 6 of the world's top 10 longest-span suspension bridges are located in China. Among them, the Wufeng Mountain Yangtze River Bridge stands as a milestone, a kilometer-scale dual-use suspension bridge for both rail and road traffic. Its completion marks China's pioneering use of suspension bridge designs in high-speed railway construction, solidifying the nation's leading position in large-span bridge-building technology. The Wufeng Mountain Yangtze River Bridge, as the world's first high-speed railway suspension bridge, sets an example for future projects. The Chinese standards it established are undeniably of global significance. It has brought China's high-speed rail into the suspension bridge era. More importantly, it ensures that the name China is the first to appear in the records of high-speed railway suspension bridges worldwide. It's hard to imagine how generation after generation of builders overcame numerous challenges such as topography, geology, hydrology, meteorology, materials, structures, and navigation. It's easy to see why China is often called the infrastructure maniac. Take New Zealand, for example. A 300-meter subway line in the city center has been under construction for 4 years, and it's still not finished. In China, a similar project would take less than 2 years to complete. Foreign construction efficiency often raises eyebrows. Work stops if it's too sunny, rainy, or windy. On top of that, they only work 6 hours a day, with much of that time spent chatting. In stark contrast, a skyscraper nearby, built by a Chinese team, is already nearing completion after less than 2 years of work. This is just a glimpse of China's infrastructure prowess. Chinese construction projects are not only reliable in quality, but also unmatched in speed. For example, dismantling a flyover takes just 8 hours, renovating a high-speed rail station takes 9 hours, and building a floor of a skyscraper takes only 7 days. These feats have left engineers around the world, especially in the United States, absolutely astonished. So, how powerful is China's infrastructure development capability? Next steps, we'll explore this fascinating topic. Let's start with some striking data. By the end of 2021, China's railway network spanned over 150,000 kilometers. Its road network reached approximately 5.28 million kilometers, and its ports boasted more than 20,000 berths for production use. The country's inland waterways stretched an impressive 128,000 kilometers. Today, China is home to the world's largest high-speed rail network, expressway system, and a network of world-class port clusters. Its comprehensive transportation network exceeds 6 million kilometers. Behind these extraordinary figures stands a remarkable team, often referred to as the infrastructure maniac. They are none other than China's infrastructure development teams. As China continues to achieve record-breaking milestones in construction, its infrastructure innovation capabilities have also seen remarkable growth. By overcoming numerous technical challenges, China has built the world's longest sea-crossing bridge, the largest water conservancy project, the highest altitude plateau railway, and the first smart high-speed railway. Now, let's experience the scene of a Chinese high-speed train departing the station. The sound is amazing. These engineering feats have left the world in awe time and again. From having nothing to its name, to building one floor in just 3 days, and then constructing 2 hospitals in just over 10 days during the COVID-19 pandemic, these examples highlight how China's engineering and construction technology is advancing step by step. Starting in the 1980s, Chinese engineers embraced independent innovation, developing groundbreaking construction equipment, including the world's first air-building machine capable of adding a new floor in just 2.5 days. China mastered kilometer-level skyscraper construction techniques, built over half of the world's 500-meter-plus super-tall buildings, and 90% of the 300-meter-plus skyscrapers within the country, securing its position as a global leader in creating iconic made-in-China landmarks. Turning to railway and highway development, before 1988, China had 0 kilometers of expressways. By the end of 2021, the total length of expressways had reached nearly 170,000 kilometers, firmly ranking first in the world. In 2008, China launched its first high-speed railway designed for speeds of 350 kilometers per hour. In just over a decade, China became the world's leading high-speed rail powerhouse. By the end of 2021, the country's railway network exceeded 150,000 kilometers, with high-speed rail accounting for over 40,000 kilometers, more than 2/3 of the global total, enough to circle the Earth's equator once. Behind these transformative achievements lies the relentless dedication of Chinese engineers. From China's first domestically designed and built railway to the world's first smart high-speed railway, over the past few decades, Chinese engineers have constructed 66% of the world's total railway length, 90% of electrified railways, 55% of high-speed railways, and 60% of urban rail projects. These achievements have written a magnificent chapter in China's infrastructure, especially in railway construction. Speaking of this, it's time to showcase China's subway track switching technology. Now, let's take a closer look at China's remarkable subway track switching technology. This is the world-renowned Chongqing Light Rail, showcasing a seamless track switching process that's nothing short of magical. The advanced technology is truly awe-inspiring, exuding a strong sense of innovation. Even Elon Musk couldn't help but praise it. He posted on his personal social media, stating, "China has incredible trains and infrastructure in general. Alright, let's keep watching." At the same time, China has independently developed a series of heavy-duty equipment, such as the first domestically made plateau, cold region, large-diameter hard rock tunnel boring machine, Snowy Pioneer, and the world's largest diameter TBM, Caucasus. It's one of the world's largest tunnel boring machines, a groundbreaking piece of technology independently developed by Chinese engineers from scratch. The successful creation of this super machine shattered a once formidable technological blockade. For years, the United States, Germany, and Japan dominated this field, leaving others behind. In the past, China had to pay an astronomical $55 million to purchase second-hand tunnel boring machines from these countries, while also incurring hefty consulting fees. But with the development of the Caucasus tunnel boring machine, China has transformed itself into a global leader in mechanical engineering, no longer reliant on foreign technology. The Caucasus tunnel boring machine measures 104 meters in length. It boasts a massive excavation diameter of 16.09 meters. Its total weight is approximately 5,000 tons. Currently employed in the construction of the Yangtze River Tunnel project, it achieves extraordinary feats, drilling over 5 kilometers continuously without replacing its cutting tools. Equipped with a mud-water circulation system and an innovative air cushion chamber, it efficiently manages mud pressure during excavation, preventing ground subsidence and collapse. This ensures the machine maintains a steady tunneling posture. It solves the long-standing global issue, frequent water leakage in large-diameter tunnel construction. Many may not be familiar with how a tunnel boring machine works. Its operation is similar to how a pendulum digs burrows. The cutting head and tools function like the pendulum's front claws, breaking through soil and excavating the tunnel. The shield serves as the pendulum's sturdy back, supporting the newly formed tunnel and preventing collapses. The soil removal system works like the pendulum's hind claws, transporting the excavated material out of the tunnel. Finally, the machine's tunnel segments resemble the pendulum's scales, reinforcing the tunnel for added strength and stability. Today, China's tunnel boring machines are entirely domestically manufactured, free from the constraints of foreign technology blockades. This remarkable achievement showcases the country's rapid progress in both large-scale machinery design and production. Today, these advancements surpass those of many developed nations. China is on track to rival, and potentially surpass, the mechanical engineering prowess of the United States and Germany. But that's not all. China has also built the first electrified railway in Tibet, the Leyland Railway, the China-Laos Railway, a flagship belt and road project. The China-Laos Railway officially began operations in 2021. Starting in Kunming, China, it crosses the border at Mohun Town and extends to Vientiane, the capital of Laos. Designed for a speed of 160 kilometers per hour, the railway adopts the Chinese standard gauge, enabling seamless connectivity with China's vast railway network. The world's longest sea-crossing rail and road bridge, the Pingtan Strait Bridge, along with many other monumental projects that benefit the country and its people, while connecting the world. With reliance on technology and self-reliance, China has also developed the largest diameter shield tunneling machine, the Jinghua, and the world's first 1,000-ton bridge erection machine, the Kunlun, both marking significant milestones. Today, the Kunlun has helped complete the world's first sea-crossing high-speed railway, and the dream of taking the high-speed train to see the sea is soon to become a reality. What you're seeing now is the world's highest bridge, the Beipan Bridge. Among the world's top 10 highest bridges, 8 are in China, and all were built after 2009. China also holds over 80 of the world's top 100 highest bridges. As a world-leading bridge design and construction company, China Communications Construction Group has built half of the top 10 largest bridges globally across various categories. This is the Zhangjiang Bridge, a monumental structure rising amid the majestic landscapes of the Wufeng Mountain National Geopark, spanning the breathtaking Jinsha River. The bridge is 1,849 meters long, with a main span of 1,080 meters, making it the 11th highest bridge in the world with a distance of 380 meters from the deck to the river below. Construction workers, with incredible perseverance and skill, have lifted 73 steel beams piece by piece to heights of over 300 meters, with the total weight of the beam segments exceeding 16,000 tons, and the heaviest piece weighing 231.3 tons. The bridge is expected to be completed by July 2025, at which time the travel time between the two banks will be reduced from an hour to just 1 minute. This is not just an engineering marvel, but a bridge that connects the hearts of people on both sides. Now, let's revisit this engineering wonder that has captivated the world. The construction journey of the bridge began on March 6, 2021, with the foundation work on Tower 5. Subsequently, the construction of the gravity anchor on June 8, 2021, and the pier columns on October 20, 2021, laid the foundation for the bridge's stability. The successful completion of the beam construction on May 4, 2022, further strengthened the bridge's structure. On December 29, 2022, the topping out of Tower 5 marked a new milestone in the bridge's construction. The erection of the catwalk on May 4, 2023, provided a safe working environment for the construction crew. Following that, on June 25, 2023, the simultaneous installation of the main cables and the pushing construction of the steel beams on the Qinglong Bank highlighted the efficiency of the bridge's construction. The first segment of the main bridge truss was lifted on September 18, 2023, taking the bridge's construction to new heights. From September 2023 to April 2024, the continuous lifting of the standard truss sections of the main bridge ensured the smooth progress of the construction. Finally, on April 28, 2024, the lifting of the closing segment of the steel truss was completed, marking the successful completion of the bridge's main structure. The Jinsha Bridge, which crosses the Jinsha River in Yunnan. The main tower is 228 meters tall, with a vertical height of 479 meters, which is equivalent to the height of a 170-story building. The height from the bridge deck to the valley bottom is 335 meters, making it the second highest bridge in the world, surpassed only by the Beipan River Bridge. The Jinsha River Bridge is currently the world's largest cable-stayed bridge spanning a mountainous gorge. With a length of 1,386 meters, consisting of 128 steel truss segments. Each individual steel truss segment weighs a staggering 175 tons, which is equivalent to the weight of over 100 family cars. The bridge's two main cables are composed of 42,000 high-strength galvanized steel wires, with a total length of 87,000 kilometers, enough to encircle the Earth twice. When it comes to the world of bridges, China's achievements are not just bragging. China's bridge construction technology is truly incredible. Next, we visit the Luzigang Bridge, a giant bridge that stretches 798 meters across a treacherous mountain valley. While its length may not compare to some of the other super bridges in this video, the Luzigang River Bridge is considered an engineering marvel. It holds the record as the world's longest single-tower suspension bridge, distinguishing itself from bridges of similar length with its sole tower, while the remaining structure is supported by cables from a distance. This bridge appears as if it's defying gravity, hanging in midair without visible support. Furthermore, this bridge was constructed in challenging terrain, extending from a 156-meter-tall tower to an anchor point at the far end of a tunnel, all on a steep slope with a 54-degree incline, setting the world record for the steepest tunnel anchor point. Despite its complexity, this bridge plays a crucial role in remote areas, becoming a key component of the 190-kilometer-long U2 expressway that connects Yunnan to major centers like Shanghai. Previously, navigating this valley took over an hour, but the Luzigang Bridge reduced that time to just 2 minutes, allowing vehicles to travel at speeds of up to 80 kilometers per hour on the 4-lane bridge. This complex megaproject started in 2019 and was completed in 3 years. This bridge has significantly improved the underdeveloped infrastructure in the mountainous regions of China, promoting economic and transportation connections in the surrounding areas. It has played a crucial role in advancing tourism and economic development in the central Yunnan region. The safety of this bridge remains a subject of debate. Our journey is not over yet. We're about to show you a bridge that is nothing short of breathtaking. The Jiaozhou River Bridge, another super bridge constrained by extreme geographical conditions, spans over 2,000 meters, connecting the provinces of Sichuan and Guizhou, with a peak height of approximately 350 meters. Constructing this bridge posed a major challenge due to the limited access to the construction site on the Sichuan side, where cliffs made it impractical for most heavy equipment traditionally employed in bridge construction to reach the area. Thus, engineers decided to build the bridge deck off-site and later transport it in 3 segments to the gorge. They used 158 cables to support the bridge deck, ensuring its proper placement using 3D visualization technology. The construction budget for this bridge was just $147 million, far lower than some of the astonishing super bridges we'll mention shortly. Then there's the Beipan River Bridge, a cable-stayed steel box girder bridge located above the Beipan River in Guizhou. Completed in 2017, it spans 1,080 meters with a vertical height from the bridge deck to the valley floor of 370 meters, equivalent to 120 stories, making it the world's 8th highest bridge. Next, we visit the Guozhou Bridge in Xinjiang, which is Xinjiang's first cable-stayed and highest bridge. It is the largest and most important bridge in Xinjiang, as well as China's first road steel truss cable-stayed bridge, considered a miracle of infrastructure construction in Xinjiang. The Guozhou Bridge spans approximately 700 meters, with the bridge deck height above the valley floor of about 200 meters. The entire main bridge is constructed using steel truss technology, with 17,000 tons of specialized bridge steel and high-strength bolt connections instead of traditional welding. Precision during installation had to be maintained within 2 millimeters, costing about $3.4 million per meter, with a total cost of $2.39 billion. In constructing the Guozhou Bridge, groundbreaking technologies were applied, such as large-volume concrete temperature control, tower and beam asynchronous construction processes, hydraulic jacking, and self-moving templates, establishing valuable experience in constructing highways in mountainous areas. The Guozhou Bridge boasts a spectacular and unique design. Its S-shaped structure winds through the valley, surrounded by towering peaks and colorful flowers. Driving across this bridge feels like being in a painting. We arrive at the Aizhai Bridge, a cable-stayed steel box girder bridge located above the Aizhai River in Hunan. Completed in 2016, it stretches 1,176 meters with a vertical height from the bridge deck to the valley floor of 336 meters, ranking it as the world's 9th highest bridge, following the Beipan Bridge, the Jinsha Bridge, and the Balu River Bridge. The long dragon-like main span resembles a great sword piercing the clouds, and it appears as a rainbow bridge, connecting the picturesque landscapes on both sides of the valley. The two towering 206-meter-tall main towers serve as the guardians of the bridge, especially dazzling at night. The cable length and height of the bridge deck above the ground also reach the world's peak. These accomplishments showcase the unwavering spirit of Chinese engineers and their relentless pursuit of the unknown. The Aizhai Bridge goes beyond human imagination, incorporating elements of harmony between people and nature, tradition and modernity. It embodies the courage of Chinese engineers in innovation and conveys respect for nature. It will undoubtedly become a lasting human miracle, inspiring future generations to stay true to their original aspirations and promote a positive cycle of harmonious development with nature. Standing on the observation deck at 200 meters high, you can not only witness the magnificent landscapes but also contemplate the harmonious coexistence of humans and nature. These are the most hair-raising bridges in China that we've shared with you. China's bridge projects are undeniably magnificent spectacles, transforming not only the country's domestic transportation and economic landscape but also showcasing China's extraordinary strength in bridge construction technology and innovation. These bridges are not just transportation facilities. They symbolize the relentless pursuit and innovation of the Chinese people, symbolizing the unyielding spirit of exploration in the face of challenging projects. China's bridge construction not only brings invaluable experience domestically but also inspires other countries to actively catch up with China's leading position in infrastructure development. Chinese engineers continue to break technological barriers by building enormous transportation bridges. These bridges are crucial elements of China's vast road network, enabling efficient and rapid transportation. It's worth mentioning that many of the world's most challenging and record-breaking bridges were designed and constructed by Chinese engineers. China's commitment to infrastructure development has created a miracle that impacts the lives of over 1 billion Chinese citizens and drives domestic economic growth. These cases demonstrate the remarkable achievements China has made in bridge construction in recent years, garnering worldwide attention and setting a positive example for other countries. The extraordinary capabilities of China in bridge construction have convinced many Americans that China is a developed country. With notable advantages in bridge design and construction, channel dredging, and manufacturing, Randi CCCC has independently designed and built Asia's largest cutter suction dredger, the Tianquan. The Tianquan can fill an entire football field with sand in just 1 hour, with a sediment transport distance of over 10,000 meters. Measuring 140 meters in length and 27.8 meters in width, it boasts a maximum dredging depth of 35 meters and a design displacement of 17,000 tons. This engineering marvel has not only broken the long-standing monopoly of Western countries but is also the largest cutter suction dredger in Asia. From spending the equivalent of 4 tons of gold to purchase dredgers from Europe and America, to now achieving technological independence, Chinese engineers and construction teams have created yet another miracle. The Tianquan is primarily used for dredging river, lake, and sea channels. Equipped with a giant cutting system at its front, it crushes seabed mud and rocks during operation. The onboard mud pumps extract the mixture, transporting it at a rate of 6,000 cubic meters per hour. This enables it to cover distances of over 10 kilometers, ensuring smooth and navigable waterways. But its capabilities go beyond dredging. Its ability to fill a football field in just 1 hour has earned it the nickname of an island-building machine. Remarkably, within just a year of completion, it was used to construct 8 islands at sea. The Tianquan represents a major leap forward for China's manufacturing industry, and it holds significant strategic importance. As a result, China has declared that this extraordinary dredger will never be sold or leased to other countries. The world's largest crane vessel, the Zhenhua 30, and a series of other heavy-duty national instruments, CCCC has also designed and constructed iconic projects such as the world's largest offshore container port, Shanghai Yangshan Port, and the world's longest sea-crossing bridge, the Hong Kong-Zhuhai-Macau Bridge. When it comes to hydropower station construction, the first thing that comes to mind is the Three Gorges project. Known as the world's largest hydropower station, the construction of the Three Gorges Dam was an enormous challenge. It took nearly 80 years from the initial planning in 1932 to the official commencement in 1994. And finally, comprehensive completion in 2006. Throughout this process, engineers had to overcome various difficulties and risks, such as diverting the flow of the upper reaches of the Yangtze River, while ensuring sufficient water continues to flow downstream. The construction of the Three Gorges Dam is a magnificent feat of the Chinese people and a model in the world of hydraulic engineering. It generates enough power in just 1 second to meet the electricity needs of an average Chinese person for over 4 years. China Power Construction and China Energy Construction played pivotal roles in the construction of the Three Gorges hydropower station. China Power Construction has undertaken nearly all major hydropower projects in China and built over 90% of the country's pumped storage power stations. It holds more than 50% of the global market share for hydraulic and hydropower engineering design and construction. The company has also participated in the world's largest south-to-north water diversion project, the Beipan Hydropower Station, the highest dam in Africa at Ethiopia's Tikis Dam, and Southeast Asia's largest hydropower station, the Malaysia Bukun Dam. Next, let's talk about the backbone of energy construction, China Energy Construction. This company has completed over 90% of electricity planning, research, consulting, surveying, and design in China, as well as the formulation of industry standards. It has handled 80% of coal-fired power plant surveys and designs, 60% of coal-fired power plant construction, 50% of large hydropower construction, and 90% of ultra-high voltage power transmission line surveying and design. It has also undertaken significant projects such as the world's largest wind-solar storage power transmission project, the first multi-terminal flexible DC transmission project, and the first ultra-high voltage multi-terminal hybrid DC project. Over the years, one bridge after another has risen, crossing treacherous landscapes. Railways stretch towards the horizon, providing convenience for people's travel. Chinese engineers have built China's roads, China's bridges, China's ports, China's tunnels, China's cities, and China's dams, shining national symbols that fuel the powerful momentum of China's economy. So, returning to the original question, how strong is China's infrastructure? From skyscrapers, railways, highways, and bridges to water conservancy, energy, and industry, from transforming a train station in 9 hours, rebuilding a flyover in 43 hours, moving a railway in 5 hours, to dismantling a bridge in 2.5 hours, you must now have the answer in your mind. The world remains the same, but China is no longer the same China. With the infrastructure powerhouse taking on the heavy responsibility and historical mission, it will continue to push forward, innovate, and drive China's giant ship steadily toward a promising future. Chinese engineers have crossed great rivers, mountains, valleys, straits, and bays, connecting this vast country as one. Initially, China had only a 9.3-kilometer railway, a steel bridge with a main span of 63 meters, and a tunnel 261 meters long. It wasn't until 1937, when the Hangzhou-Qiantang River Bridge was completed, that China had its first self-designed and built railroad bridge. However, to resist the Japanese invasion, the bridge's designer, Mr. Mao Yisheng, had to personally destroy it. It wasn't until the founding of the People's Republic of China that the bridge was fully repaired and rebuilt. In 1957, the Wuhan Yangtze River Bridge was completed, allowing the Chinese to cross the Yangtze River for the first time. Young bridge engineers overcame numerous challenges, successfully designing and building the Nanjing Yangtze River Bridge. Thus, the once distant railways on both sides of the Yangtze were finally connected, giving rise to two major transportation arteries, the Beijing-Wenzhou and Beijing-Shanghai railways. However, the span of these bridges remained limited, unable to accommodate more complex geographical conditions. It wasn't until 1991, with the completion of the Nanpu Bridge in Shanghai, that China began building large-span bridges independently. Since then, China's bridges have become increasingly diverse and grand, not only spanning the Yangtze with a single arch but also soaring across canyons at an altitude of 565.4 meters. Meanwhile, underground tunnel engineering has also made remarkable progress. It took China nearly a century to build its first 10,000-meter tunnel, but in just over 20 years, the country achieved breakthroughs of 20,000 meters and even 30,000 meters. In the past, the Qinghai-Tibet Railway had to climb 600 meters and take 2 hours to cross Guanzhou Mountain, but today, a 32,690-meter-long tunnel allows a direct 20-minute passage through the mountain. It is thanks to thousands of tunnels and millions of bridges that China has overcome countless natural barriers, connecting railways and highways to all corners of the country. China now has the world's largest high-speed network and high-speed rail network. This fully connected China can transport 17.6 billion passengers and 462 tons of cargo annually to every corner of the world. Behind these vast numbers is a monumental reorganization of population and resources. Over the course of more than a century, China has connected, reorganized, and rebuilt, breaking the environmental constraints that once held back this land and creating a unique transportation network. 100 years later, the Chinese have reshaped the land. Looking back at the past, the Chinese entered the 21st century carrying the national humiliation of the Eight-Nation Alliance occupying Beijing during the Qing dynasty. However, through the relentless efforts of generations of Chinese people, this once fractured country has finally been restored and unified. China, a nation of resilience and determination, has always commanded utmost respect. Its hard-working people embody the essence of perseverance and dedication. Despite facing numerous challenges and enduring profound pain, they never cease to strive for greatness. China's indomitable spirit is a testament to its unwavering commitment to excellence. In times of adversity, China's deep understanding of humanity shines bright. Their profound philosophical insights encapsulate the essence of compassion, empathy, and unity. China's philosophy of life is a boundless source of wisdom, guiding individuals toward a deeper understanding of the human experience. With its rich history and cultural heritage, China has left an indelible mark on the world. The achievements of its people and their relentless pursuit of progress inspire admiration and awe. Their unwavering determination to make China the best resonates with the hearts of millions. China's contributions to humanity are truly remarkable. From revolutionary advancements in technology and science to promoting peace and harmony in a rapidly changing world, China has proven to be a guiding light for humankind. The values ingrained in Chinese culture, such as respect, integrity, and honor, serve as a beacon of inspiration for people around the world. Let us celebrate China, a nation that continues to grow and prosper against all odds. Let us cherish its commitment to humanity and tireless efforts to uplift both the nation and the world. China's unwavering spirit and deep understanding of humanity elevate it to a position of admiration and respect. May China continue to shine bright, leading the way toward a better and more compassionate future for all. The journey through China's mega projects is one of awe and inspiration, a testament to human ingenuity, innovation, and the relentless pursuit of progress. Each of China's major projects showcases the remarkable feats that can be achieved when vision, technology, and sheer determination come together. If you found this video insightful, give it a thumbs up and share it with others. We would love to hear your thoughts and insights in the comment section below. Don't forget to like this video and subscribe to our channel to stay updated with more fascinating content. Thank you for watching, and we look forward to seeing you in the next video. Let's continue to explore, learn, and inspire together. Take care and goodbye.